Question number 11. Electron volt, EV, is unit of power, energy, charge, voltage, potential difference. We have found in the first video, electron volt is the unit of energy. Then answer is 2 for the question number 11. Then 12. In the following expression, I and V represent current and voltage respectively. C is the constant. Then term KT over Q has. We have to find the dimensions of KT over Q term. Then I will write given equation C log I over I naught plus 1 equals to QV over KT. We know that for a log term there is no dimension. Therefore, for this term there is no dimensions and C is a constant value. Therefore, C has no dimensions. Then in this equation, left hand side no dimensions. Therefore, we can get QV over KT also no dimensions. We can write as 1 dimensions as 1 because of there is no dimension. Then we can subject given term KT over Q. KT over Q dimensions should be equals to dimensions of V. They have given V is a voltage. Therefore, dimensions of V is dimensions for KT over Q term. Then answer is 5 for the question number 12. Then question number 13. Rate of decay A of a radioactive sample with time t is given by relationship A equals A naught e to the power minus lambda t. The dimensions of lambda t is a power. We know that power has no dimensions. Therefore, we can get lambda t is the power. Therefore, dimensions of lambda t term should be 1. 1 means there is no dimension. Then we can subject lambda. Dimensions of lambda should be equals to dimensions of t. 1 over t. T is the time. Therefore, we can substitute capital T is dimensions for time. Then answer should be t to the power minus 1. T to the power minus 1 is second answer. Then second one is the correct answer for the question number 13. Then 14. In the equation C equals K over rho root. C is speed and rho density, the units of Kr. I will write the equation. C equals K over rho root. C is the speed. Therefore, we can substitute unit of C ms minus 1. This is the unit of velocity or speed. We have to find unit of K. I will use K term without any change, and rho is density. We know that density is kg m minus 3 is the unit for density. Then we have to find the unit of K. I will get the square of equation m squared t to the power minus 2 equals to K divided by kg m to the power minus 3. Then we can subject K. Then we can bring kg over m to the power minus 3 to the left hand side. M squared s to the power minus 2 multiplied by kg m to the power minus 3 is unit of K. Then kg, we can simplify m terms, meters terms, m to the power 2 multiplied by m to the power minus 3. Then answer is m to the power minus 1, s to the power minus 2. Then correct answer is kg m minus 1, s to the power minus 2. Answer is 4 for the question number 14. Then question number 15. Which of the following is not an SI unit? They have given first answer kilogram. We know that kilogram is SI unit for mass. Then it is a SI unit. Then meters is the SI unit of length. Therefore, it also a SI unit. Then third answer, seconds is the SI unit of time. Fourth answer, ampere is the SI unit of electric current. Fifth answer is kilo. It is in simple K. Simple K means kilo. It is not a SI unit. Therefore, answer is 5 for the question number 15. Answer is 5 for the question number 15. Then question number 16. Dimension of a certain physical quantity when multiplied by L to the power 3 gives the dimension of work the physical quantity would be. I will consider the physical quantity as x. Then they have given when multiplying physical quantity by L to the power 3, answer should be dimensions of work or energy. We know that dimensions of work ml squared t to the power minus 2. Then we can subject x ml squared t to the power minus 2 divided by L cube. We can cancel out 2 terms. M L to the power minus 1 t to the power minus 2. We know that these dimensions are dimensions of pressure or dimensions of Young's modulus. In this question, they have given third answer is pressure. Then question number answer is 3 for the question number 16. Then 17. Dimensions of kilowatt hour is. We know that we are using kilowatt hours to measure energy consumption or electricity unit. It means energy. Then dimensions of kilowatt hour should be dimensions of energy. We know that dimensions of energy ml squared t to the power minus 2. Then answer is 1 for the question number 17. Then question number 18. Energy E of a photon of frequency f is given by E equals hf. The dimensions of h are. We can write equation E equals hf. It is the energy of a photon. We can subject h, E divided by s. E is the energy. Energy is work done. We know that dimensions of energy ml squared t to the power minus 2. We have to divide by dimensions of frequency. Dimensions of frequency t to the power minus 1. Then we can cancel out 1 t to the power minus 1 term. Answer should be ml squared t to the power minus 1. ml squared t to the power minus 1. Then answer is 1 for the question number 18. Then 19. SI unit of the quantity of heat is. We know that heat is an energy type. Heat is an energy type. Therefore, dimensions of heat should be dimensions of energy and unit of heat should be unit of energy. In this answer, fourth answer is joules. We know that SI unit of energy is joule. Then answer should be 4 for the question number 19. Then question number 20. Which of the following does not represent fundamental unit in SI system? We know that there are 7 fundamental physical quantities in physics. We have discussed in first video. You can watch it and then we can get the answer. We know that m is meters. It is used to measure length. Length is a fundamental physical quantity. Newton, second answer is given as Newton. Newton is force. Force is not a fundamental physical quantity. Force is a derived physical quantity. Therefore, Newton is not represented in the fundamental unit. Then answer should be Newton. Second answer for the question number 20.